All right, so this is Python programming part 3. This is Brian Fagan again, working at Lumpkin County Middle School. All those details haven't changed. So it is continuing on a series of looking at different programs. I try to talk a little bit about how I integrate activities into the programs and use activities to introduce the programs. And then try to challenge you in some way for the next week. So hopefully you've been practicing programming, or these have been somewhat useful to you. You can always go back and rewatch them. They do follow along the Teach Your Kids to Code book, so this is sort of a good way if you're going through the book and you want some additional ideas. This is also a good place to start, so you can kind of go back and watch this series. I think there'll be 7 total in the series before we're done. As always, a couple of resources that I like to use. Python.org is a great website. It's very intuitive, easy to use. All the examples are there that you need. And then you can download Python at python.org downloads. And the current version is 3.6.4. So in a couple of parts, I'm going to introduce a couple of other aspects of Python and how to organize your programs. And I actually got that from another teacher on EdWeb who was using a different format, and I downloaded that and really liked it. So I'll introduce that once I get a little bit more familiar with it. Teach Your Kids to Code is the book that I teach from. There's obviously lots of other books out there that you can use. This is a great book for middle school aged children, if that's where you're starting. Has great examples, great progression, and all of the codes are available for free. So you can actually get access to all those codes and integrate those programs into your classroom. And there's an Udemy course that you can go watch on how to use the programs, and also some extensions to those programs. So there's plenty of resources if you want to begin teaching Python in your classroom. And then you have the Python standard library where you can access all of the examples for different functions and features that you might want to use. Standards alignment to the CSTAs. This is just some variables and program development standards that connect to what we're doing. Today's programs are going to be kind of working more looking at mathematical computations, and I'm also going to leave the comments. I have more comments in these programs today, so you can kind of see how comments are used. They're really good to have and definitely necessary when you're writing shorter programs. It can kind of get in the way, particularly when you're teaching. Sometimes the students get bogged down with writing the comments, and so I kind of use both sometimes. I'll have one example with the comments on and one example with them off, and just kind of helping them see just the program, but also see the practice of commenting, because it's really important that we include comments in our programs, particularly if you want someone to come back or someone intends to come back and use your program or build from that foundation. If you're working in a team and multiple persons are working on one program, it's really important to notate using comments inside of your code what you're doing and what you're intending to do. So these are the again the standards. So we'll be creating a program, naming variables. We'll fix errors if we make any mistakes. We'll use correct terminology. We'll debug and use comments in our code also. The 2 programs we're going to look at today, again, our theme is numbers and variables. We'll be looking at a program called Atlanta Pizza and looking at a program called Math Homework. So both these programs are number heavy, variable heavy, and use mathematical computation as sort of the focus of what they do. One activity-based program that I do, one way that I introduce, generally after Atlanta Pizza, but I like to have a collection of comic books, just the worthless $1 comic books. You can probably get a box of comics at the comic book store for 10 or 15 bucks. maybe even cheaper. And a lot of times, if you talk to your local comic book store and let them know that you're teachers, they tend to give you there's lots of comics and resources and things they can give you. But what I do here is I have a box of old comics in my room. Kind of let the students kind of flip through them, look through them, read about the Amazing Spider-Man or the old X-Men comics, and you kind of can talk about, if you've read comics in the past, sort of which ones you like or don't like. You can get into a conversation of superheroes, and the whole intention here is just to kind of get them excited about the topic. I then ask them to rewrite the Atlanta Pizza program to calculate the value of the comic collection. And you can divide them up into groups. This group take, a third of the box. This group take a third of the box. And we look at just the face value of the comic, the price of the comic, the day that it was purchased or the day it was originally sold. And we rewrite the Atlanta Pizza program to calculate the cost of the comic book collection. You can go back and look at some of the value that's accrued over time. And maybe find the increase in value. But again, the comic books are just the hook. It's just the catch in order to get them excited. Now they have the comics at their table, they're looking at them, they're writing down their values, and they're more excited about writing the program. So, and in all reality, this is something that you would actually do. You may not sit down and write a program just to add up your comic book collection, but in a way you do. When you kind of price them in your head or you write the values down on paper. We're just taking it a step farther and writing a program that they can use, and so they find that fun. A couple of things that we'll learn today or be able to do. We'll be able to write our own variables and store numbers, strings, and lists. We'll look at different number types in Python. We'll use basic math operators and perform calculations. We'll have strings, numbers, and lists. We'll use lots of comments to help build our code, and we'll look at a variety of situations of how inputs are used. So one of the first programs that, and again, I'm going to leave the comments on this time. The comments are all in red. They have the hashtag preceding them. If I delete the hashtag, the color of that line of code changes. It's no longer a comment. It needs to be preceded by the hashtag in order to be a comment. So this is a simple pizza cost calculator. It allows us to store information as a variable. And then we can multiply those variables or add those variables later in order to get out a total cost for our pizza, including tax. So it's kind of a neat way of doing calculations. So the first comment we have here is Atlanta Pizza. This is the name of our program, and it's a very short descriptor. You can definitely include a longer descriptor if you want. If you're teaching 8th graders or high schoolers, you may encourage them to detail their program or provide more detail about their program. 6th graders, I generally have them just hashtag their name and hashtag the program name. That way I know who wrote the program and what the name of the program is. And then I also encourage them to save the program as that program name. So they're all named the same thing. But this is sort of an in-between there. So we have the name of the program. We don't have the author of the program, so we can go back and add that. And it includes just a brief description. It's a simple pizza cost calculator. So our next comment is we are asking the person how many pizzas they want, and we get that number using an eval function. So we're attaching that eval function to our input function. So we have the number of pizzas is the variable, and we're using sort of a different naming system for number of pizzas. Variables need to be all one word, but they can be made up of different words. So in this case, it's number of pizzas. I could delete out the underscores and just leave it as number of pizzas, but what I cannot do is have it written out as number of pizzas with spaces. That is not interpreted as being a variable. So this will definitely mess your program up. Since I'm choosing to use underscores later in the program, I will return these back to number of pizzas using underscores equals an eval. And then we're looking for the user to input some information, and we prompt them with this string here, strings being inside the quotation marks. How many pizzas do you want? So that is going to appear on the screen. They're going to see the prompt, how many pizzas do they want, and they'll have a blinking cursor so they can type in some value. The next thing we need to ask the person is what is the cost of each pizza? And so we're using the same variable naming type here, cost per pizza. Again, we're looking for an input from the user. How much does each pizza cost? And they can type in the cost of each pizza. And here's sort of the neat thing you can do with variables is we're setting up a third variable to get our subtotal. It's essentially the number of pizzas multiplied by the cost per pizza. Since that number is going to vary depending on who is running the program, we can't put any specific value in there. But what we can do is use the variable names that are storing that value. So in this case, we can actually take number of pizzas and multiply it by cost per pizza, just using the variable names. We don't have to have any actual numerical value here because it's stored as that variable. That's one thing the eval function allows us to do uniquely is multiply these variable names together as mathematical operations. So in this case, we have the subtotal is going to be equal to the number of pizzas times the cost per pizza. One of the things to remember is when you're using variables is to make sure you name them the same everywhere that you want to use them in your program. It's one reason why I keep mine all very simple. I generally don't use underscores. It's just I don't know why. I'm using them here to show you the difference of how you can use them, but I tend not to. But just make sure that you are typing these variable names the same way that you had initialized them. Okay, so our next calculation, this will give us our subtotal. Our next calculation is initializing or defining the sales tax. So we have a variable called tax rate, and we're setting it equal to 8% using the decimal value here, and we have it stored. This is the way you want to input it. You don't want to put 8 percentage sign, so 0.08 is the correct way to enter that as 8%. So that's now stored as our tax rate, and in order to get our total sales tax, we have to multiply the subtotal times the tax rate. And we're doing the same technique here. So we're just taking a new variable called sales tax, and we're setting it equal to the output of subtotal times tax rate. The tax rate, we could have just typed in the value here. We could have ignored this step here, initializing tax rate, and just typed in 0.08. But what it allows you to do is to change the tax rate later without having to go back through everywhere in your program where you want to use tax rate and change that value again. So for example, if we wanted this to be 10, that automatically changes the value here also. Because we're using a variable here for our tax rate, we only have to change it once. And everywhere that we use tax rate will also change with it. So it's really important, even if you only intend to to use it once or twice. It's better practice to go ahead and just set it up as a variable and then use it. So we have our subtotal times tax rate. That gives us our sales tax. Right now we need to add the sales tax to the subtotal for the final total. That's our new variable called total equals subtotal plus the sales tax gives us our total cost. It's much easier to kind of write this out on the board or kind of walk through the steps with them. Sometimes you can bring in, you could do it Atlanta cookie or something and bring in the cookies and kind of show them and have them figure it out as sort of an incentive to kind of work through each step. So they kind of know each step, but some of them may not be familiar with how tax and stuff is added in, so it's kind of a lesson that you can use there too. All right, so once we have the total is equal to subtotal plus sales tax, and then down here we're just going to print out or print to the screen the information that we've gathered. So the first thing we're going to print is the total cost in dollars is the total, whatever the variable total is equal to. Then we're going to break that into the subtotal. This includes subtotal for the pizza and the amount in sales tax. So it's going to divide up that subtotal, that initial total before we added in tax, and then it's going to show us how much has been added in sales tax. So we'll run this real quick. So it says, how many pizzas do you want? I'm going to say, I'm pretty hungry, so I'm going to do 16 pizzas. And it says, how much does each pizza cost? We're going to do, I'm not even sure how much pizzas cost these days, so we're going to say $9.99. That's maybe an expensive pizza. So the total cost of our pizza is $172.63. This includes $159.84 for the pizza and $12 and roughly 79 cents in sales tax. So it breaks that down for you. Then you can run it again using different numbers. I think Little Caesars. And it gives you your $26 is the total. $26.95 is the total cost. This includes $24.95 in total, and about $2 worth of sales tax. So, and I have them use this similar program to similar. They rewrite it, but they use this same program when they do the calculate the comic book collection cost. A couple of things you can do down here. You can make it a little bit cleaner. You can add these /ends to skip spaces as each piece of text is being printed to the screen. We want that one to stay together, so we'll leave that together. I tend to like that, so it separates things better. It's much easier to read. So the last sentence is a complete sentence, so we kind of leave that together. So I generally have them go back and add those things in. And those are things that once they learn them, they will kind of use on their own. They'll kind of remember that stuff. All right, so again, this is a very simple program to use. You can use it in a variety of different ways. You can change the sales tax. You can run it over and over again and give them actual examples of products and costs and have them calculate it. There's different environments where sales tax is different. So you can have them, graph their information. You can do lots of different things from this basic program. So one that I do like. All right, the second one we're going to look at is a little bit shorter, but it is a math homework calculator. It's just a very simple program for just doing some mathematical calculations, but it does use does give them the option. One of the first times one of the first programs in the series that I have them write, where the program continues until they decide that they want to quit. And we have a condition here that allows us to quit the program when we want to quit it. So again, we're going to leave the comments on, since that's one of the things that we're kind of looking at this time. So print is going to print the screen. I'm going to go back up here and add my name. I like to encourage them to hashtag their name and the program name. We'll just call this math. We'll just call it math right now, math calculator. And then they can, depending on the age group, again, you can provide a program description. We'll just put it as a calculator for the day. Just save time. You can just keep it simple. Depending on the age, you can have them again write a more detailed description. So the very first thing that's going to happen is this is going to print math homework calculator. It kind of just starts the program. And then our comment here is we're going to ask the user to enter a math problem. So we're going to set a variable problem equal to an input, right? And we're going to prompt the user to enter a math problem or type in lowercase q to quit. And so this program is going to continue to loop and ask for math problems until they enter Q to quit. Up until now, they've had to run the program every single time, run module, and then run it. Well, that's a little bit slow for a calculator, particularly if you're using it to work on some problems. You want your calculator to kind of always be ready. In this case, it's always going to be ready to input a math problem up until the point that you hit Q to quit. So we have our variable problem. We are setting it equal to a user input, and we are prompting them to enter a math problem. It's going to keep going until the user enters Q to quit. So we have while problem is not equal to Q. So this exclamation mark left of an equal sign means not equal to. So while problem is not equal to Q, I want you to continue to do these things, continue to loop and do the things that I have within this while loop. And the two things that we have show the problem and the answer. So we print the answer to the problem. The answer to 2 plus 2 is, right, and it evaluates the problem. So it inputs the problem here, it evaluates and prints the solution. Then we just repeat asking for another problem. So since this is a loop, as soon as the program finishes evaluating your problem and printing it to the screen, it comes down to the next command, which is the same as the very first one. We have a variable called problem. It's equal to a user input, and we are prompting them for another math problem. And as long as they don't type in lowercase q, it's going to loop back around. It's going to solve the problem and print it to the screen, then ask for another math problem. If they type in a math problem, it's going to loop back around. It's not equal to q, so it's going to solve the problem and then ask for another problem. If they type in the letter Q, then as it loops back around, problem will be equal to Q, and it will no longer go through the loop. And it's actually going to come down here, and we can actually print down here just to show that we exited the loop. We can put calculator off if we wanted to. Now I'll just prove or just show, make sure that we've exited this while loop using the letter Q. This could be quit if you wanted to, and they would have to type in quit. It's a little bit easier to just leave it as Q, but you can set your conditions to what you want them to be. So we have our comments, we have our initial just showing the calculator is on. The program is running. We ask for a math problem, As long as that problem is not equal to Q, we're going to solve the problem and then ask for another one. As soon as they type in the letter Q, we're going to skip past the while loop and print calculator is off. So let's just run that and see how it looks real quick. All right, so we have our math homework calculator. It's printing, the prompt here, enter a math problem or Q to quit. So I'm just going to type in 2 plus 2. All right, the answer to 2 plus 2 is 4. And then if we put these side by side, we're still inside this loop. So it's asking us for another math problem because we didn't enter Q to quit. So I'm going to do 10 times 10, right? And we're still inside that loop because we didn't enter Q to quit. If we enter Q to quit, right, it jumps down and says calculator off. I would probably go back and add some spacing in here. I like it to be a little bit cleaner, so I'm going to do a /n here. That puts a space in between. Let's put 1 / in there, and you can actually put these at the end of the strings also. And we're going to do a, so let's run that again just to see some changes. So we have our math homework calculator. We're going to do 12 times 12. The answer to 12 times 12 is 144. Enter Q to quit. We enter Q to quit, and it turns our calculator off. The spacing's a little bit better, I feel like. It's a little easier to see. So just to bring both programs up side by side, both of them were heavy with math calculations. We left the comments in this time, a little bit more detail with the comments. We used a new function eval, which we kind of introduced over here, and then we saw how it was better used over here. Within our print function, we used the eval function to solve our problem, which was stored as our variable called problem. So when I typed in 2 plus 2 or 10 times 10, the program evaluated that solution here and just input the solution right there when it outputted it. So again, you can rewrite and modify these programs in a lot of different ways. I like to use the Atlanta Pizza as a foundation for our comic book collection calculator. And I generally get with the math teachers for the specific grade that I'm teaching, and we try to look at some of the problems and calculations they're doing in class. We try to use our calculator for those also, just kind of do a check. So they kind of find that neat that they're using a program they've written, not just the calculator, which ends up being a calculator anyways, but they've written the program that's used to solve the problem. So they tend to like that. All right, so just to kind of recap, we used comments, we looked at strings, numbers, lists, we looked at the steps and comments that help us build our code. Very number heavy this time. And again, to go back, you can always make extensions of these programs, provide real world examples for how they can use them in their classroom. Part 4, I guess, will be in about a week and a half, so look forward to it. Thank you.